In this video, we will learn what are scatter plots and where are they used. Now, a scatter plot is a type of graph that uses plotted points to show patterns in bivariate data. Let's understand what this actually means. So, scatter plots or scatter diagrams are basically graphs where we are going to plot points from the data we have already collected. Now, this data is going to be bivariate. Bivariate means two variables. In this case, we always in graphs we see two variables, right? One is the x and one is the y. The x axis is x and the y axis is y. And then we check what pattern these points are showing us and understand what kind of relationship is between this x and y. Let's actually look at a real life example to understand what I'm talking. Another thing about scatter plot is whenever I make a scatter plot, when if I find a pattern, it will help me predict what may happen in the future.
On into your notes. Okay, so here's our example of a scatter plot. Anytime you find a scatter plot, you're going to do the same thing you do when you look at any graph, which is you're going to check out the title, right? That might seem really obvious, but a lot of people miss that part. So we're actually looking at Old Faithful eruptions, right? And if you're not familiar with Old Faithful, here's a picture of it. It's a geyser in Wyoming, in Yellowstone National Park, and it gets its name because it is very faithful in the way that it erupts. It's very reliable and predictable. And this scatter plot shows data collected from Old Faithful eruptions. All right, we are looking at a bivariate data set, which means that we have two variables. Okay, that was part of our previous video. So we have an x value and a y value. Right, and so there we have an x and a y axis, and both of those axes are labeled. All right, so we're looking at the duration of an eruption, or how long an eruption lasts, and the amount of time you have to wait between eruptions. Okay, so when we take a look at our actual scatter plot here, each one of these points represents an eruption. Right, so this particular point right here is documenting an eruption that lasted just over 5 minutes. And after that eruption, it was almost an hour and 40 minutes until it erupted again.
So, in case you are having a doubt of what are eruptions, you must have heard the word volcanic eruptions, right? Where lava flows from the middle of the mountain and all. So, here we are looking at geysers. Geysers are like, what do I say, hot water eruptions. So, suddenly hot water starts coming, and it's not really safe for people to go nearby because, of course, hot water will burn the skin and something like that. Yeah.
Okay, this particular point right here is talking about an eruption that lasted about 2.5 minutes, almost 2.5 minutes. And after that eruption, there was just over 50 minutes before the next eruption occurred. Okay, so as we look at the scatter plot, it's starting to tell us a story. I see two row clusters of data here emerging. Okay, I see this cluster of points here of short eruptions, and when these eruptions are short, meaning less than 2.5 or 3 minutes, generally the amount of time that you have to wait until the next one is also shorter. Okay, but when the eruption is longer, when the eruption lasts, 4 minutes or more, then you're going to have to wait longer until the next eruption occurs. Right? So the longer the eruption, the longer you wait until the next one.
So here the person actually found a pattern in this particular scatter plot where she understood that when the eruption is for shorter duration, the waiting time is also shorter for the next eruption to occur. When the eruption is for longer duration, the waiting time is also longer. How is this going to help me? In case for the same particular eruption, I want to predict what might happen in the future. And suppose I had a reading that eruption started and it lasted for 5 minutes, and someone wants to know how much more time do we have for the next eruption to have. Excuse me. and from my and from my scatter plot, I can clearly tell that, okay, there are high chances that the next eruption may happen mostly after 80 minutes. So, this is helping me, this particular scatter plot is actually helping me predict how many minutes of waiting time is there before the next eruption. Now, what are these patterns and how do I understand? These patterns are also called as correlation. Now, let's look at what correlation means.
And the shorter the eruption is. Video. The Old Faithful erupts and how long relations. Okay, so a correlation is an association or a relationship between quantities, right? Again, on our Old Faithful scatter plot here, where there's a relationship or a correlation between how long an eruption lasts and how long you have to wait till the.
So, these correlations are of three types. Let's look at the type of correlations that are there. So these are the different type of correlation. So in a scatter plot, after marking the xy points, if my points look that they are moving in a positive direction or like this upward direction, then it is called a positive correlation. If they are moving towards downwards, then it is called a negative correlation. And if you see at this particular scatter plot, there is not really a particular pattern you can see here. It's not really moving up or down, it's scattered all around here. So in this case, we will say there is no correlation at all. It means my x and my y are not impacting each other. What can be some examples? For positive correlation, we can say that maybe the number of hours I study and my score in the examination, right? We all know that maybe if I put in more effort in studying, my score in the examination keeps increasing. Now, what can a negative correlation look like? A negative correlation can look something like um, the number of hours I sleep at night and the number of hours I watch TV. So if I'm watching TV for longer time, the amount of sleep I may get at night will be lesser. But if I watch TV for if I watch TV for less time, the number of hours of sleep I get will be more. So this can be an example of negative correlation. What is no correlation at all? No correlation can look like the vegetable I'm eating and the marks I'm getting. So if I'm eating 10 carrots in a week, maybe my marks are somewhere here. My If I'm eating 40 carrots a week, maybe my marks are somewhere here. So basically, there is no relation between the number of carrots I'm eating in a week and the marks I'm getting in math. So those are the cases of no correlation.